Alright, folks. Welcome back, everyone. 皆さん、おかえりなさい。今日は132日目です。It is day 132. Get into our lessons. We started after midnight. That's why these are filled. Let's get into our 3 for today. Light? Copula. Interesting. Okay. Yeah. We got the gozaimasu, right? With... Wait. Oh, no. Wait. Yes. Interesting. So as mentioned briefly in the gozaimasu lesson, de gozaimasu is a structure which can be used as a replacement for de arimasu, the polite form of de aru, which itself is the formal equivalent of da. Hold on. I see. Both this and de gozaimasu are considered polite speech, yeah. However, de gozaimasu is the most polite of the two. Let's take a few. Alright, we're just going down the list.
郵便局は隣でございます。
Alright, I see.
運転手の田中でございます。
De gozaru may also be seen as is the base form of de plus gozaimasu, a special class verb. However, in modern Japanese, this is primarily restricted to historical drama or characters that have somewhat quirky personality. Yeah.
拙者が服部でござる。
Okay. I see. Okay. Using de gozaimasu to introduce yourself is considered quite polite. However, when referring to other people, irasharu to be is preferred, as honorific language is more respectful than polite speech, yeah. Which is our previous points. Okay. Both polite, right? One just happens to be extremely polite, the other one is more commonly used in everyday conversation. Fair enough. Oh, there, Procon. How's study going? It's going pretty alright. How's it going at your end? Da is the casual and informal form. In contrast, we have the super polite form. Okay. Another honorific. Let's see. Oh, well, this is humble speech. Okay. Yeah, to humbly do something. I get it. So let me guess, you have a verb in between? Okay. Or what? Oh, and a pseudo verb. Pseudo verb use. Go. No. All good on your end? Excellent. Good to hear. Alright, so we got the o and the pseudo comes from a form of polite speech in Japanese called humble speech. This type of speech is used to refer to the speaker and their actions. Right? As opposed to something opposed to outside the speaker. This is opposed to honorific language, which refers exclusively to the listener and their action. Okay. O and suru is almost exactly the same as o and ninaru, as in it simply means suru, okay? So o suru is regularly used with words of Japanese origin. Right, while go and suru will be used with words of Chinese origin. The suru in this compound will attach directly to the mas stem of almost any verb. Okay. So this is talking about the speaker and its action.
僕がお守りします。
I see.
今すぐにご確認します。
Okay. while the suru in this structure will attach directly to the mas stem of verbs, this does not mean that verbs that are already suru will become shisuru. In the case of suru verbs, we simply add the prefix go. Interesting. So, go登録する方はこちらをクリックしてください。click. Okay, クリックしてください。Okay. Right. I got it. Okay. And this is order, right? Yeah. 注文。そう、ご注文するときはこちらのベルを押してください。Okay. In rare cases, all may be used instead of go when attached to words of Chinese origin. There's no specific rule for this, and they must be memorized on a case-by-case basis. Okay, which example are we getting? Odenwa suru. Okay, yeah. Senpai ni odenwa suru no ga suki desu. Okay, yeah. 友達とお勉強するのは楽しいです。Okay, fair enough. Thankfully, the words of Chinese origin that use o instead of go are extremely common words. Verbs, yeah, we have denwa and benkyo. This means that they'll be exposed to that you will be exposed to almost all of them very quickly. All others may be assumed to use go. Fair enough. Fun fact, in the same way that o ni naru is a common variation of nasaru. Okay. Right. O suru is a very common variation of itasu. Itasu, I don't think we have a grammar point on itasu yet. Itasu. 5分後に電話します。Interesting. Fair enough. 5分後にお電話します。And I don't remember what the contrast is. I guess we'll learn soon enough. It might actually be the next grammar point. Yeah, this is it. Itasu. Itasu. Okay. Let's see. Itasu, or the kanji form as it is often written, is a humble speech, right? Ooh. Okay, so Godan. Fair enough. Which refers to the action of the speaker, right? Or people within the speaker's inner circle, like their company. Similar to osuru, itasu means to do. In the case of suru, verbs themselves simply replace suru with itasu. Yep. For other verbs, add itasu to the mas stem of the verb while attaching o or go to the beginning, depending on whether it's a word of Chinese, Japanese, or Chinese origin, right?
私たちが用意いたします。コートはこちらでお預かりいたします。
お預かり。Okay, yeah, look after yourself. Okay, do that.
こちらからご連絡いたします。
ご連絡。 Words that include the kanji. I mean that is worship, but hi, oh man, haven't used that in a while, in a hot minute. Hi or to revere do not usually require o or go or itasu because it's implied. This is due to the word itself being respectful. Yeah. So 私は親戚のお寺を拝見する at most. Yep. So you don't need, yeah, fair enough. Wait, they still, what? Wait. Don't usually require, but they still showed an example in which it used it? Or are they talking about? Huh. I'm not sure. 先輩からお金をハイジャックする. Intriguing. Fun fact, Itasu is considered to be slightly more humble than Osuru. I imagine that's also the case for other relationship, which means that it will be heard more frequently in advertisements or being used by company. So we have Suru, which is the casual, right? Standard, neutral. Or actually, Suru is just neutral. Then we have Nasaru. And Nasaru is... Okay, wait. Itasu is the humble form of Suru, right? Itasu is the humble form of Suru, used when talking about your own actions to someone respected. For example, right, means akarai in a different way. Nasaru is the opposite, which it talks referring to the person's action, right? But I don't know if Nasaru has the same relationship with Ninaru that Itasu has with Suru. I don't remember. Guess we'll find out time. And I gotta remember these are stems. I need stems. Alright. I can't tell. I can't tell. Oh no. I really can't tell. Oh no.
この方は田中さんでございます。
Okay. What gives this away? Not really. Yeah, I can't tell. Oh boy. Other than having the Kenjogo listed there. Oh no. I don't recall. Oh, right. We have to attach it. Okay. Oh, that's what they mean by... Okay. I see. That's what they mean by suru. Okay. So they're telling you to use the equivalent. So, shime, right? Because, and then this is shimeri, right? What was the... I don't remember. It's not that. Oh no, I guess you only need oshime. And then, oh, this is the suru.
ドアをお閉めします。
Okay, I need to get... Okay, so the verb stem is... Okay. I won't be able to tell the difference in the reviews. Which one's which. Yeah, that's gonna be a tough one. Like between polite speech and honorific language. Oh, I guess the honorific language, as long as it includes the honorific. But maybe not so much they're talking about the listener or the speaker. Interesting. Alright. We are 20 vocabulary. Alright, we got more katakana word. That's gonna be a tough one. Because there's no okay. Alright. What is this? Torena. Okay. That's gonna be a problem too, because I might add it. Like torena, as opposed to torena. Okay. What do we have here? Seike gairyo. No. Seike Geka. Whoa. Hold up. Oh wait, yeah, I get it. So Geka is coming from surgery. Geka. And then Seike. Orthopedic, really? Seike. Hold up. Alright, so we got arrange shape. Oh, I see. Orthopedic. Oh, okay. Fair enough. That's gonna be a little tough. It makes sense. Surgery that deals with shape and form. Okay. That's definitely new. Orthopedic. Even orthopedic is new. Or that combination. I don't even have seike. Seike. What is this? Tetsu. Oh, tetsuya. Fair enough. That's no. Fuska kan. 2日間. Okay, that's fine. 2日間. I wonder why they chose 2. 奨学金. Oh, we just got 奨学金 in Manikani recently. 旅行会社. 旅行会社. Alright. Self-explanatory. 降り出す. Begin to rain. Or just begin to fall, really. Begin to precipitate. 降り出す. Okay. Tetsu? Or tachi? Oh no, that's tachi. Tachi for adding to pluralize things. Right, watashi tachi. Mudachi. Mudazukai. Mutazukai. Oh, mutazukai. Okay, so mudazukai. So muda is futility. We just got that. Just now. Or yesterday actually. And then zukai. Zukai is the hard. Or like is that the same zukai? Okay. Hold up. Hold the phone. Oh, it's not. Wait. Dispatch. Oh, to use. I see. Right. This is doing the use thing. And zukai was the kozukai. Kozukai for allowance. And then we have zukai can go off tsukau as well. With the rendaku. Yeah. For to use. Not actually one of the vocabulary, but it's combining 2 of the vocabulary words. Okay. So mudazukai. Mudazukai. Landlord. Okay. Oh. Oh, that is different. Oh, Oya-san. I mean, it makes sense, sort of? Oh, yeah.
Oya-san.
Oya-san. I mean, I get it. It's interesting. So this ended up being O, and this is Ya. Oya-san. Interesting. Landlord. Okay, it's fine. Oh yeah, X-ray. It's named for the guy. Rentogen. That's a tough one to remember though. Oh, mochi, wait. Mochi, oh, mochi, doshi. Mochi doshi. Interesting. So doshi is like a long thing and you're waiting for a long time. Interesting. Longed for, anxiously waiting.
待ち遠しい
Oh, not machi. I'm saying machi. I'm saying mall for whatever reason. Machi doshi. Machi
Machidoshi.
Doshi. Okay. I think that one's okay. Tuition, that it's kind of on the weaker side. Some of these are new terms, like 3 or 4 new terms. Yu-Gi-Oh! Yu-Gi-Oh! Ryo. Yu-Gi-Oh! Ryo. That's understandable. Yu-Gi-Oh! Ryo. Yu-Gi-Oh! Yu-Gi-Oh! Ryo. Kaigo. No, Kaiwa. Kaiwa, just have English conversation. Kaiwa. Grinning. Nia nia. Nia nia for grinning, huh? It's either you know it or you know it. You know it or you know it. No exceptions. Oh, so we got our otolaryngologist, which makes sense. Ear, nose. So what is that? We're just gonna do. Oh, wow. Jibika. Whoa. I thought it might be like Mibika, Jibika. I think we're just gonna have to we either know it or not. I just gotta know it. Kinda like otolaryngology. You either know it or you don't. This would be kind of funny if you can get away with just saying like Mimi ya, right? Mimi ya ana isha desu. Or no isha desu. Like ear and nose doctor or something, as opposed to like doing that, or like gaku. That's kind of funny. That's probably them. All right, back to basics. Jinko is, and then sensu, fair enough. All right, so we got some really weird ones. A hairstyle achieved by chemically treating the hair to create long-lasting curls or wave. You gotta remember that there's no All right. Oh, and there's no Okay. A non-Japanese word for a type of casual sportswear often worn for exercise or leisure activities. Oh, that type of turena. Okay. Turena.
Trainer.
I'm gonna botch this at some point, because I'm gonna add a somewhere, and I'm gonna add a somewhere at some point. A medical specialty focused on treating muscular skeletal injuries and disorder. Okay, so we're emphasizing shape, right? I only remember the K part. Arrangements. So we're arranging the shapes. And we got these. And then surgery. Geka. Right. The practice of staying awake throughout the entire night, often the practice of staying awake throughout the entire night, often to complete work or tasks. Okay. So the withdrawing part, or the thoroughness, the penetrance part, then the penetrating through the night, so staying all the night or throughout the night. An expression indicating a duration or period of 2 days. Right. Financial aid or support provided to students to help with their education. That one's fine. A business that specializes in planning and arranging travel-related services for clients. This is fine too. We're adding company and travel together. Oh, and I gotta remember that there's a rendaku here. An unexpected rendaku. So, ryoko gaisha. A verb indicating that precipitation such as rain or snow will begin to fall often. This is a grammar point too, for using dasu. Dasu to suddenly begin. So, got the furidasu. Pretty standard. A suffix used in Japanese to indicate a group of, like, plural form of something, primarily indicates living things. Tachi. The act of spending or using, that's a grammar point. The act of spending or using resources without a productive result. Now this is a combination too, and it's a combination of a new one and a slightly new one. So we got the muda, which is pointless or futility. Muda, and then use with the rendaku. So zukai, as opposed to tsukai. Okay. The owner or manager of a rental property, such as an apartment or house. Double kun with an with a like a ending, a respectful ending. So, oh yes. A filler word that indicates that the speaker is thinking about what to say next, right? Or it could just be however, but okay. A medical imaging technique that uses electromagnetic radiation to view internal structure of the bone. Okay. Oh. Like then.
Rentgen.
Okay. A phrasal adjective expressing excitement or anticipation for something in the future. Okay. And then this is a combo verb to combo adjective. So waiting, so mochi, right? And then a long time. So do, using do for extended or long distance, right? And then shi. So machidoshi, machidoshi. The fee charged for attending an educational institution or being enrolled in a class. So we have class, jugyo, and added with fee, ryo. So jugyo ryo. Okay, the act of conversing in the English language or a place where this skill is developed. So we have talk, wa, added to meeting and English. So English meeting conversation. So English conversation. English meet speak. So Ekai wa. Ekai wa. And then our you know it or you don't situation, an onomatopoeic word describing a sly or mischievous expression created with the mouth. Interesting. Nya nya. Nya nya. Kind of sounds like nya nya. Alright. A medical specialty focused on ear, nose, and throat issues, right? So they only included the ears and nose, and it's a special read for ears and nose. G is special, and then B is honestly, it's actually kind of cool. It's wait, let me think about this for a moment. What is? Oh, just kidding. R dual R. That doesn't work. All right, it's fine. This is just gonna be special in general. So GPK. Ka is more for study field, so that's pretty good. B is fine actually. B is fine. G is rare. Something created or produced by humans rather than occurring naturally. AI. Haha. There it is. And who thought Japanese wasn't ahead of their time? I'm kidding, obviously. Jinko. I imagine this was a pure coincidence. Jinko. Something artificial or man-made. AI. Jinko. A handheld fan with collapsible. Yeah, it's one of the first words you learn. Man-made. A handheld fan with collapsible blades, often used for cooling oneself. Right. Sensu. Alright, let's get into this. I lost the I lost which character it was. Penetrate, right? But what? That's it.
何のためにあなたは徹夜したのですか？
あなたたちはここで何をしているの？
大家さんと喧嘩をしてしまいました。
私はあの選手のトレーナーとして働いている。
Ah. What? Oh, Pama, not
私の母
Moo.
の髪
Oh
はパーマ
no.
です。
Pama is gonna be a problem. It's Pama, not Pamu. Wow. Okay, Pama. I'm gonna tell you. Like those. The adopted words, I tell you. Adopted words. Pama is it's an adopted word. Heck with loans and borrows. That's not a borrowed.
これは人工の髪でできたウィッグだ。
留学生活が待ち遠しいです。
Uh. What? Did I screw up? Oh, no, wait. No, we're fine. Oops. Oh, wait.
僕の両親は整形外科で働いている。
Oops. Wait.
「今日から2日間旅行に行く予定だ」。
英会話の勉強をする。
大学で耳鼻科について勉強する。
It's gone.
レントゲン写真を撮る。
写真。奨学
優秀な生徒に奨学金を与える。
奨学金。いや、酔えるの与える。
センスとうちはどっちが欲しい？
Interesting. I didn't quite think they were separate things. Huh. Do you know what parietal cells do? Like, you mean in the body? Like your parietal cells in your stomach? Yeah. Why the... What's up with the parietal cells? They're the reason you get heartburn. Not, well, sort of, yes. They're pretty much one of the reasons you get heartburn. You were just curious as to how our body creates acid in our stomach? Transfer of acid. I know that doesn't explain too much, but transfer of protons. Proton transport chain. In a different way to say it would be a gastric proton pump, or like a proton potassium ATPase pump. Acid-base chemistry, or biochemistry, I suppose. So it's the transfer of protons. This type of proton, like acidic proton. Apparently H2O, CO2, and chloride in all your body needs to create acid. Yep, that's all you need. So most of your acids and whatnot are created by counter ions, and CO2 is the carrier because it forms carbonic acid. And then you have a very strong molecule like chlorine to accept protons to create HCl, which is the primary acidic compound for your gastric acid. Your body transfers protons via carbonic acid and carbonate, or carbon dioxide and carbonate and carbonic acid. It's in like equilibrium, like most of it is in equilibrium. So you have a pump, you have a protein pump that is powered by a potassium protein, like a potassium proton channel that's powered by ATPase. And your ATPase, it requires this too, not just H2O and CO2. It requires all the proteins as well. This is the ATPase, and it uses energy in the form of ATP to go against the concentration gradient. So it allows you to build acid up a gradient, build up a gradient. So it requires energy. The body requires energy to push and build against its concentration gradient. So you need a protein channel that can be activated by an energy source, which the body circulates ATP, right? Adenosine triphosphate. And this acts as a source to pump and exchange the energy to move protons up against its concentration gradient. Does it break down any chemical molecules to create acid? No, it's in equilibrium. And if so, it is actually splitting the bonds? No, these are all covalent bonds. So, we have to keep in mind that most of these are covalent bonds. So bonds do, quote unquote, break, so to speak. But it's not the same as ionic bonds. I think oftentimes when people think about splitting bonds, they're talking about ionic bonds. But ionic bonds are very strong and it liberates energy and all that stuff. But these are covalent bonds. So covalent bonds is like dipoles meeting each other and whatnot. So they're not as strong, they're tenuous. So like when you have kind of these types of bonds, and then like acid-base chemistry is constantly with the exchange of protons. So these are covalent bonds, and they're often in equilibrium. So like your EQs, your equilibrium constants that you're measuring, because these are dynamic states. An ionic bond tends to be viewed as like a very stable type of bond where the lowest energy state is the state that it remains in, and it requires a lot of energy to break those bonds, like heat and a very strong way to break ionic bonds. But covalent bonds are tenuous. They're based on concentration. So like if you add, right, weak acids, right, like carbonic acid is what's in your body, it freely exchanges with another like base. Another base would be chlorine. So it just depends on which one has a stronger attraction to it, and it just takes it off. And this strongest attraction is affected by equilibrium, or your concentration gradients. So when there's a high concentration of something, it usually tries to go down in concentration to equilibrate, basically. And it requires energy, like in the form of ATP, to create a imbalance of concentration gradients. So your stomach requiring more acidic environment than the surrounding environment, and if it's permeable, if the membrane is permeable to something, the only thing that's keeping it from like reaching equilibrium or like equilibrating is an active energy source to maintain the imbalance. But most things, like in covalent bonds, if you have like organic acids and base together, they will equilibrate. They will come to like an equal amount of each. So they'll rearrange and like form covalent bonds with each other in a manner that there's forces, like the forces and concentration will equalize. It's kind of hard to view it as a form of energy, but it's kind of like equilibrating energy. The whole solution, the acid-base solution, forms an equilibrium. So it comes to an equilibrium state that you could view it as a low energy state. Ionic bonds are like, I actually know very little about ionic bonds. This is where like there's inorganic chemistry and biochemistry. I know there's also organic chemistry, right? You have in college you have organic chemistry and inorganics, but typically you don't talk inorganics, it's just everything else. The organic chemistry is dealing with like the synthesis and the pathways of synthesizing the chemistry part. And then the stuff that I'm talking about is biochemistry, which involves a property that is still taught in organic chemistry and inorganic chemistry, but in the context of the body, stuff like equilibrium constants and pumps and local concentration is more of the focus. So I really know very little about ionic compounds, like, and inorganics. The closest things are, since my background is in biochemistry, I typically, the closest thing I get to like ionic compounds and stuff is like minerals. So like coenzyme activation. So things like iron, right? Iron, chloride, potassium, sodium, zinc. Is zinc Zn or is it Zc? It's Zn, right? Yeah, so all your like minerals and vitamins, your vitamins, as you know, your vitamins, and coenzymes and vitamins are the large majority of any potential ionic bonds, but they're not ionic bonds either. They're like they're weaker covalent, like valence bond related things. Like these things typically have like, they're water soluble. So there's water solubility and fat solubility. That's where all these terms are typically in reference to biochemistry, not necessarily chemistry. So it's one of those things that illustrate how you just think of things, they're technically the same thing and they're all unifying. Like, you know, physics could unify these things for sure, but the depth of how you portray the chemistry in a system is very well, it's like makes you really feel the impact of how exclusive some of the terminology is. And the way I'm describing like ATP and acid-base chemistry is based on chemistry, biochemistry, not organic or inorganic chemistry. Reminds you of maybe your favorite conversation, physics versus chemistry versus biology. Yeah. So the way I'm explaining things will sound potentially like if a chemist walks in the room, right? And the way I just described acid-base chemistry as an equilibrium with like a dynamic covalent bonds dealing with the physiological local concentration of your like parietal cells in your parietal cells versus like the the cavity of your stomach, right? That type of thing, it would be like very hard to appreciate or be very argumentative, because from a chemistry standpoint, trying to explain the chemistry that occurs would take on a different life of its own. And since I'm not a very well-studied chemist, I can't really describe it in a manner of like energy states or something like that. Like physics and chemistry, there's thermodynamics and kinetics involved, and largely all I think about is equilibrium and like concentration gradients when it comes to like biological systems. You think about like local concentrations. If the concentration is higher there, you know, it, like for example, water, osmotic pressure, that's something that biochemists would take into account. While you saw, you know, permeability, water, or hydrophobicity and like hydrophilicity, I suppose, which those are the things that you're concerned about. But in chemistry, you would have to explain that stuff differently, like with numbers and energy and kinetics and whatnot. And then physics, you would have to explain it in terms of bonds, right? Something that would probably make a physicist cringe when a biochemist or a biologist explains something like as a proton. That's kind of cringy, like, or disagreeable, so to speak, because it's not really a proton. It's like more than a proton. So whenever you think of, when I think of biochemistry, it's like you have a cursory understanding of the deeper chemistry, and you kind of wiggle around with physics terminology. So then when a physicist walks in the room, they're like, you're basically just hand waving all the interesting physics stuff. It's like, yeah, because it's more on the context of the biological system. And then in chemistry, it's like, dude, there's some interesting chemistry there. So when you were asking about like, do bonds get created? Is there a chemical modification, or are there ionic bonds? Yes and no. But at the same time, it wouldn't be for a biochemist to specifically be involved in thinking about, yeah. So when I was trying to explain it, I was like hand waving the physics and hand waving the organic chemistry and applying more so concentration gradients and carrier like acid-base chemistry. I think acid-base chemistry is the most familiar because it's responsible for many of the biochemical reactions that happen, like a proton pump. Proton pumps, like membrane proton pumps, are legitimately one of the major principles that you have to understand in a biological system, like how a proton pump works. And then the rest are enzymes. So when you think about chemistry and physics, rarely do this word comes up. It just doesn't come up very often. And you're concerned about the mechanics of enzymes. So like you have your ATPases, your phosphatases, and anything that ends with an ace is you're in the realm of biology, like amylases, right? You have amylases in your mouth. That's where the first peptases, or I'm gonna call them like protein aces, are, and carbo, I'm like making up words now, carboaces. So all your like macromolecules and their respective enzymes. And then when it hits the stomach, you have others like, or peptides, semi-complex carbohydrates, and then your lipases, right? Your lipases, which is lipids. So that's what, in my opinion, what you will probably hear from a biochemist, which my background was in biochemistry, as opposed to hearing about how these compounds are stabilized and their substituents, right? Like, sure, carbohydrates are typically like some form of carbohydrate, like, you know, CHO, right? And then your lipids are typically hydrocarbons, right? Hydrocarbons. And then I would start to draw like models, right? Like glucose, right? As a ring. And I don't remember its chirality, so I have no idea what arrangement of glucose is. This is part of biochemistry though. Unfortunately, my memory is slipping. Like what the arrangement is for glucose, and then obviously fructose is 3, right? Not 3, 5. However, I do not remember the substituent arrangement of the carbohydrates anymore. If I see glucose, I'll be able to recognize it's glucose. But if I can't output it anymore. That's kind of like language. It's the same thing here. Learning a language. If you do not output the knowledge, it doesn't mean you don't know the knowledge. You're not instructionally outputting it anymore. So if someone showed me the structure of various six ring carbon compounds, I am very likely to pick out what is glucose, and like sucrose, sucralose, and like various others, or like a nitrogenous base or something like that, like a phosphatase part, and then like what a coenzyme might look like, or maybe even the nebulous structure of like a GTPase or something like that. Maybe like the crystal structure of a few of the more common things, like like you have your double helical like scissor shapes and whatnot. But I can tell you now, a structural, we're delving into the realm of structural biology and crystallography when you're thinking about protein structures, which again, as a biochemist who doesn't have too much experience, I see the overall shape of crystal structures and like structural biology. And when I think about like the mechanics, like a helice, like like a tunnel in a protein shape, that's structural biology. When you get to structural biology, like they're more concerned about like the stability, right? Stability and folding of proteins, which I have no idea. I simply use the terms very generically. Like, oh, here's the pocket, you have like you have a shape, and then you might have a groove, like, and then you have like a groove here for like the whatever the substrate is, and then you might have like a tunneling thing for the protein pump. But generally speaking, my field that I worked in, we look at these as structure of function, as opposed to like the kinetics and the folding stability and interaction points, like the entropy of these types of things, like energy states and different conformations of protein structures. When you go to a university that has an umbrella program, usually cellular, cell, molecular, structural, biophysical development, and I might be missing a discipline here, but these three tend to be together. So when you are in a program, you would have to know you would be in one of these, and you're responsible to be interdisciplinary for the others. because your colleagues and other mentors in the program you need to have at least the foundational understanding of the other disciplines. So all of these things, and then these split up as well. So you like cell further splits up. Unfortunately, I don't know how they split them up. I was in molecular. That's why I typically say molecular biology, and specifically I studied viruses, right? So molecular can also be a protein lab, right? A protein lab. You can still be a protein forward specialist in any of these areas. Like biophysical doesn't necessarily have to be about proteins. It could be about like ionic compounds. I don't know what type of interest there is. So, and then there's usually like when I was there, bioinformatics and like silicon computational work was on the rise. So these would be typically all the fields that you have to be responsible for. So you're not going into a department for just biology. This is biology. So whenever someone says, oh, you know, we had our conversation about physics, chemistry, biology, right? This is the bio department. The bio department looks like this. During my time, which is almost 10 years ago now, like you can see that there's subdivisions that aren't even listed here yet because genetics is part of it. So genetics belong to one of these layers of interaction. You can see like structural, biophysical, development, molecular, and cell has different like tiers of emergence, like how they study, the methodology that they use to study a phenomenon. Then you have semantical breakdowns like genetics, virology, like oncology, in terms of developmental biology, my embryogenesis, right? So then you have contextual disciplines, but generally all of this is biology. That is what biology is. Now, if you go to the chem department, which I've only went to the chem department like once, it's usually in an entirely different building. The chem department would be split up too, like, you know, organics from inorganics, right? There might be separation when it comes to like crystallography. I imagine the chem department is structured like this too. And then I have no idea how physics work, so I'm not gonna even touch physics. I've only walked in the chem department once. Physics, I would likely think that physics would have something that's kind of even lower, like lower as in like foundational than chemistry, because in chem you have like instrumental. There's instrumental chemistry, right? Instrumental chemistry is like all the analytic tools like a multi-TOF and mass spectrometry and whatnot. But I don't know if that leads in with the physics department, because the physics department might have something to do with the instrumentation. But chemistry, one of the departments that I'm very familiar with is the instrumental department, which is dealing with analytical tools. And that would be like a mass spec, a multi-TOF. I know these are all acronyms, but they're used to measure different molecules, like different compounds. So at like your ionic bonds and compounds, all those things file under instrumental. So sometimes a biologist would get help from a chemist, especially one in instrumental background, to do that, right? It's interesting. Oh, and biology, there's also one that isn't. My department did not have a large behavioral component, so there's still or like on the level of the organism, right? Behavioral. I don't know how the university's psychology department is broken up, but some of the biology department people do have some neurobio stuff, but neurobio was not a department, so, or like a subdivision of biology. But you would expect that a really large bio department would also have neurobiology as a separate discipline under biology. Neurobio or psychobio. I did have colleagues that worked with neurobio and like optical, like things that are dealing with the organ level. The organ level, like large organs level, and then the organismal level, like behavioral at the very top level. But that's about it. And no human. There's no human studies, so to speak, because we didn't have clinical, right? Clinical would be the other thing. A clinical department. I was in a basic research animal, like kind of animal and smaller organism model department. We didn't have clinicals. We get samples by collaborating with a clinical department, which is the med school. So the department that I went to was not the medical school branch, but we do go to the medical school branch to get clinical stuff, like clinical samples or tissue samples or something from patients and whatnot. What would you call the levels of explanation from biology to chemistry to physics? You don't quite know how to word it, but using the wrong word for an example. As biology gets more precise, it starts to become chemistry, and as chemistry starts to get more precise, it starts to become... the word would be... yeah, precise is pretty good. I would say resolution. I would say resolution is probably the word you're looking for. So like systems, maybe like systems resolution. So like physics looks at the lowest resolution, like the highest resolution, depending on which way you're going. Like, so the precision you're talking about, using precision will be like misleading, right? Because biology and chemistry and physics have relatively similar precision. You require precision to publish something, and they hold each other to acceptable precisions based on like mathematics and sample size things. But I think it's more so systems resolution. So at what level, quote unquote, level of resolution are you looking at when you're investigating a system, right? Are you looking at it at the subatomic, right, subatomic level? Are you looking at it on a molecular level? Or not a molecular level, but maybe like a element level or a molecular level? And then it goes higher, like a cellular level, you know, and then a small systems level with like an organelle or something. Or not, actually, we're already past the organelle. Maybe like an organ, and so on. I think it deals with the resolution level, like what level of the system's resolution you're looking at. When it comes to precision, nearly every discipline has a standardized precision that it must reach. So it's incomprehensibly incomparable. Like, for example, you can't compare a 95% confidence interval from biology for a very specific sporadic phenomenon to a 99% confidence interval for a synthetic pathway synthetic pathway for, like, I don't know, a ionic compound, some sort of ionic compound of choice, right? In chemistry, these are incomprehensibly incomparable. Like, so this would provide an argument for precision, right? How precise it is. That would be misleading if we were to go for precision. And also reproducibility. That would be another word that you would line up with precision. Like, for example, you would make an argument that physics is more precise, or so inferring that is more reproducible. They're incomprehensibly incomparable in that nature. Like, if you attempt to apply physics principles to a system like biology, that confidence interval will probably be very similar. Like, what I mean is the tolerance that physics would have to undergo is creating that. Links into the precision versus accuracy per recall. All of it. They are incomprehensibly incomparable. That's like taking a mathematical principle and applying them equally across 3 disciplines without knowing its conditions. Right? That's kind of like taking a number and not knowing its standard deviation. Like, oh, I could tell you I have a 99% average rate, but the SD would be like 10% or something like that. Like all of these things would be incomprehensible to each other. So not quite the way to distinguish. At least in my opinion, I wouldn't distinguish biology, chemistry, and physics by any inclination of mathematics. Let's see. And then as biology gets right. We've previously established that going from physics explanation to chemistry and then to biology generally moves towards emergence. Yes, like level resolution. My use of resolution level is inferring from our discussion of emergence. Whenever there is a clear classical, maybe even or dogmatic to some extent, emergence level, then that is a step in a discipline. So when I was organizing the bio department and I was saying various things like biochem at the top, right? Then, molecular, cell, structural. It's more like sufficient emergence to separate the fields. So categorically, the way going from like bio to chem, there is a degree of separation between them, which deals with their emergent properties that are now well known between them. So as chemistry, biochem becomes more detailed, one can continue to subdivide a discipline based on its emergence. So there's an emergence of something that segregates a discipline, that's when they become more disciplined. Like chemistry could be viewed as all organic and inorganic together. However, at some point, the principles that involved in understanding organic chemistry versus inorganic chemistry has created an emergence. Like more details into understanding chemistry created 2 separate disciplines, because the way organic chemistry is focused rarely applies to, like, it has a large significant emergence that is not overlapping with inorganics. So much like cell has an emergence that is very different from molecular biology. So cell bio versus molecular bio. The stuff that you would say and look at in molecular does involve cell biology. The thing is, the language and the details that you're using are so emergent that rarely it can be interesting. Like, it can involve things that they're studying in cellular biology. You simply understand that they exist or they happen. That's why I was describing, like, going back to our first thing about protons and ATPase pumps, right? Because of the emergence of these pumps in the biological system that typically require that occurs, this would be kind of linked in the area of biochem, protein biochem, as opposed to like a chemistry discipline. But in chemistry, you can describe the acid-base equilibrium and what's creating that. And then in the emergence of physics, you can describe the energy states, that how this occurs. So all the systems can still be characterized by the different disciplines. The idea is, when you go to speak or describe the system, they are emergent in the sense that it is very difficult to communicate between them. That's how I would say it, but that's a negative way to say it. They are different sufficiently enough that it will require a focus point, and then everything else would be tangential to it. So like maybe a point of specialization, I suppose. Significant enough for specialization. So I don't think chemistry, physics, and biology is no more precise, accurate, or like it's just precision and accuracy. That type of thing is coming from a singular discipline. So if you're thinking like that, then it's pretty much considering the idea that you prescribe that one discipline is the only way to describe a system, which is pretty much what happens when emergence slaps you in the face and you have no idea how to explain it anymore. The whole idea of emergence is that you can even say, my lack of understanding of physics is an emergent property whenever I study a system using what I understand about molecular biology. So whenever there's an emergent observation, I would consult the other disciplines, and hopefully those emergent properties belong to the specialization of the other disciplines to help me, right? Like, dang, I don't understand the molecular kinetics or like the kinetics of the local concentration of viruses when the host is infected, like the general dynamics of it. That would be an emergent observation that I require. So then I would go and consult possibly like a structural biologist, or maybe like someone who knows more about like concentration gradients in organic, like in like a simulated, like they could simulate the environment or something. There's so many ways that it would go. And typically when I think of emergent things, I think about things that are outside, that come up, that you observe, not necessarily just the universal emergence, which is what I feel people who like physics tend to refer to it, where you're talking about if all is true, then emergence is outside what we all know, which that's not typically how I look at emergence. What is emergence is whenever a biologist can't explain something that chemistry can explain. So when you observe something and you're like, I can't explain this with my existing things, I need to collaborate with someone else, it's an emergence of a new observation. Like, it is an emergence of the data. It has come to my attention that genetics involve a phenomenon that I did not account for. So that creates more disciplines, right? Like the disciplines of bioinformatics, for example. I could argue by my definition, so my qualifications, not like anyone else's, because I don't know what the science field does anymore. I could say that bioinformatics was the emergence of genetics. So in order to understand the increasingly high complexity of genetics and like the area that I was studying, we needed computational power. And at the interface of computational power, like CS, bioinformatics, the field of bioinformatics, was an emergent discipline from genetics and computational science. So you combine them, and now bioinformatics has such a specialization and a nuance that it is now an emergent discipline. So now when I do genetics, I may have to consult with a bioinformatician or learn that discipline myself, because it is an emergent property that I have yet to investigate in my system. So whenever you're looking at an experiment, anything that's outside that you didn't account for can be considered an emergent property of the system you're studying. Now, whether we all know it as a collective, that is typically not what I'm thinking about when I'm thinking about emergent properties. A physicist, in my opinion, someone who thinks that the world knowledge, like you treat the human's body, like the entire human body, like all of science body as one collective, then yes, emergence can be defined by like certain levels, like biology, chemistry, and physics, if you want to be like super general. However, in science, at least from my experience from biology, that is not really realistic. It is not on the scope or even the resolution level of one's discipline. So working in science typically humbles the human being. So whenever someone speaks like, oh, you could generically segregate and categorize these things, I would say that is coming from someone who may not have worked in the discipline that they're talking about, or work in a level of depth in which they've been humbled by their lack of foresight or lack of ability to be all-knowing, right? And for myself, that's not a bad or a good thing. The idea is, the cool thing about knowing more is there are going to be more emergent properties. And for myself, like how I categorize things, that's not set in stone, because it depends, right? So what does it depend on? The perspective of the discipline. So whichever discipline you belong to, your background, your makeup, will affect the way you interpret and segregate and categorize your discipline, right? I'm a biologist. primarily. So the ways I categorize the disciplines are from the perspective of what is relevant to biological systems, and not even biological systems at the resolution of like your kidney or your heart or your brain. You can probably have a better shot at arranging a perspective by that from like a doctor or like a clinician, right? A clinician would likely segregate at that particular resolution level. When I'm thinking of molecular biology, I'm talking about molecular on the scale of molecular things. So like I would segregate disciplines based on like proteins, enzymes, chemicals, even nucleic acids. So like compounds like nitrogenous, like I would even further maybe like subcategorize nitrogenous stuff and hydrocarbons. So that's the way I would like categorize them because of my discipline. Now, if you ask a physicist, they would categorize differently, and it is their level of emergence, in my opinion. So whichever they can conceive as different levels of emergence is for the categorization. So going from bio to chemistry to physics, in my opinion, is your dogmatic categorization for someone who is outside of all three disciplines. So if you have someone who is outside of biology, chemistry, or physics, this would be the dogmatic approach to separate the three disciplines. And then since I'm in biology, I would separate chemistry and physics based on how biology is segregated or emergent. So like chemistry is a molecular discipline. Physics is a kinetics and thermodynamic property of biology. So the discipline itself, you could say borrow. I think the word I would use is integrate interdisciplinary based on their needs. So then I don't know too many chemists, and I know even fewer physicists. So of the chemists that I might know, they would describe biology like things like acid-base, right? Acid-base chemistry, right? Acid-base chemistry. We have our EQs, our solubility constants, diffusion, right? Diffusion gradients, stuff like that. So they would take those phenomenons and then recategorize them in the perspective of chemists. And that's their emergence. Like diffusion is clearly not quite the same as solubility. Acid is not quite the same as base, so you don't categorize them together or something like that. Or like metal, metal interactions, like your oxygenation stuff can be categorized differently from your carbon related things, stuff like that. I'm being very general because again, it's been a very long time. We've previously established that do you think that going the other way is going towards reductionism, or do you think it could also create emergence? Either, like in all directions. I kind of indirectly answered that question about how I interpret emergence. Emergence is dealing with the speciation of nuance between disciplines. So when it can lead to new disciplines at any level, it requires that the detail expands in a way that elicits a new way of looking at something. Because humans are not omniscient, they are collective, right? And the whole idea is when you're saying reductionism, you're talking about the human collective, not any particular human in particular disciplines. because we are still individuals. And then the way you look and analyze systems is from the perspective of the individual that then communicates with the collective, not reductionism as an entire group. But you can view and try to look at it that way. And reductionism would not be the word I would be looking for, because reductionism would mean that there's it would suggest that something is smaller and something is bigger in various aspects. I'm using very general words because that's how it feels when someone is using the word reductionism. Unless they're really inferring that there is, again, less precision, less resolution, that's relative. If you tell me everything, all the protons and neutrons of a system, it would fail to capture an organ's function. So there isn't like a reductionism happening. Like going this way is not reductionism. Going this way is not reductionism either. They simply are on different levels of emergence. At least in my opinion. So like this describes the system, and this also describes the system. They're at different emergent levels. So there's no reducing or expanding or any of that. Yeah, resolution sounds like the right word for it, which funnily enough links to your comment before this one with emergence and redux. Yeah, links in, and by your understanding your definition of emergent, it's far broader than I thought of it as. Yeah, because I've changed the way I looked at emergence because of this person who so they did simulations. They did a lot of simulations, right? And their input came from experimental studies, like wet lab experimental studies. However, the things that they describe from the simulations, they describe them as emergent properties. And the interesting way this person used it, I found to be very agreeable, which is the idea that when you do your methodology, which your methodology is defined often by your discipline. Despite having systems that are maybe well characterized, for example, well characterized in one discipline, right? One discipline, when it is lifted to another discipline, it can still observe emergent properties. So I found that far more agreeable as a definition for emergence, because the discoverability when two disciplines interact with each other, that doesn't separate them based on emergence. Like what I mean is, like when chemistry interacts with biology and that interaction leads to the discovery of an emergent property, it's neither chemistry nor biology, it's both. So when you're trying to use emergence or precision or like reduction or something in the way of keeping the disciplines separated, then you can't account for when they're together, it leads to emergent properties. Like without this simulation, for example, you could argue, well, with enough input in experimental like scrutiny, you can still discover this emergent property using discipline 1. Like, well, we'll never know. So oftentimes emergent properties come from various combinations. So my thought is a more agreeable definition of emergence in order to align with categorization is defining the properties themselves, the occurrence, the emergence of properties. And that constitutes what biology became, and what chemistry became, and what physics became, and then all of their subdivisions. Is not defined by a collective in an attempt to separate the disciplines. Again, I'm very biased because I was educated in an interdisciplinary way. I didn't go to, I don't even know if they exist anymore. Like, I'm not even sure if they exist. I think it's incredibly dogmatic. It's incredibly dogmatic to view physics as not chemistry, and physics as not biology. Just as the same as biology is being viewed as not physics. And this is 10 years ago. I'm not even sure what it's like now. That's like saying, I don't know, electricity, like an electrician, or like, let me see. Which you can still, like, people still do this, obviously, if you take a different approach in defining things. I'm not saying I'm correct about this. This is my perspective. Like, it's like saying I am a smartphone engineer. So therefore, smartphone engineer is not an electrician. Or this is why I have a really hard time communicating what it's like to be a scholar. Because a scholar sees the connections between all of them. They're not trying to segregate. They're learning just sufficiently enough to keep on pursuing with their time. So it's not that you're a physicist, so therefore you ignore any chemical and biological component based on your emergence. Like, you're a physicist now, so now because you can perceive the emergence of chemistry and biology, you're going to segregate them and never touch those disciplines just because you're a physicist. That, to me, in my opinion, is dogmatic. It is the old way. And it's still tried and true. I'm gonna be real. I'm gonna draw criticisms for this. Someone's gonna come by and say, well, physics is so deep that you don't ever have to touch chemistry or biology ever in your life. It's like, okay, well, I agree with that statement. It is your choice and your prerogative, right? However, for me, I was taught in an interdisciplinary way. So when I don't understand a phenomenon that can't be explained by the way I'm approaching things, I would consult other disciplines, because those other disciplines are emergent from my perspective. I cannot perceive it at the moment. And through the synergistic or the integration of both those disciplines, like maybe chemistry, a side of physics, lump them together, then a new emergent property can occur, or like the observation of that new emergent phenomenon can occur. It's not through any one particular discipline, which in my opinion is what happens with dogmatic values, especially physics. Like, I know, like, I know we talked about this before, and I'm not saying physicists should feel bad about this or something like that. It's like they have so much going on that they're trying to unify, and the way they think about things makes sense. They're trying to explain everything. That's, I guess, like, that's I have to respect that type of perspective, right? However, for me, as a biologist, physics is not off limits. Chemistry is not off limits. I cannot explain a biological system without talking about physics or chemistry. And no, talking about biology doesn't mean it's not physics. That's kind of the like dogmatic thing that I learned to appreciate in graduate school. Like, especially if you go to graduate school or you become a higher scholar, you find that it is very difficult to define things arbitrarily by a level of importance or like precision or reductiveness, or like you entertain as many possibilities as possible. Because if you can't explain a phenomenon, then it's emergent from your perspective, your knowledge. If you can't understand something and you've done everything you possibly can with what you know, it is emergent from what you're trying to explain. So to increase the chance or likelihood of understanding that emergent property, your emergent property of a system you're looking at, you would incorporate other disciplines. And you want, in my opinion, and I don't know if this has ever happened, I'm sure it has happened at least in the last 10 years. I would want to be part of a department of science where physicists, chemists, and biologists routinely consult each other. And that was kind of the vision before I left science. The vision is that you have a department that naturally consults each other. And we're not even talking about the subdivisions, because in my bio department, all those departments, they consult, like they interact with each other at on a regular basis. And it's tough because you can't be it's tough to constantly think about other people's concepts when they may or may not be germane to your research. And I've been really tired before where I would listen. It's kind of like you speak English, right? And you go into a Japanese speaking seminar and you sit there and you try to be interested. That was the, if I had to prescribe like PhD, right? My breakthrough, if I had to prescribe any type of breakthrough from my education in graduate school, is the idea that one must find interest. Otherwise, you're not gonna circumvent dogmatic, probably I'm gonna say dogmatic ego, because dogmatic ego restricts one person's lifetime of being able to understand whatever they're trying to observe. So that's the discussion that we typically have, but not in like a ideological way. The ideology typically is us, them, we, that, or this, that, yes, no, white, black, chemistry, biology. And it paves pretty much most of my conversations. Like, rarely do I say, oh, you're wrong, let me explain the right way to think about this. Right? It's more like we're collectively discussing. So when you're describing things, you must integrate the information that is provided to you. So like when someone says they disagree with you, right? Right now someone could come in and say, no, physics is the GOAT, right? Physics is goated. Then I would ask them, can you explain this? Can you qualify all of these things? And then I would integrate their information into my discussion. That is the soul of an interdisciplinary scientist or a researcher or a scholar. You're not sweeping things away based on your emergence level. Like, oh, well, that's not important, right? So it's outside of your emergence. Like, it's an emergent property that you don't care about. When someone disagrees with you, you can ignore all the things that they say if you choose to not listen to them. That is outside your realm. So you are completely blind by choice and ignorant by choice to ignore everything this person is saying. Alternatively, you can take what this person is saying and integrate it. Now your perspective has the potential to be emergent. So a discussion, exchange ideas have emergent potential. A one-way slap fight, argument, and debate about who's right and who's wrong so you can negate and discard, that's not emergent. That is truly reductive. So if I wanted to go back and use the word that you were using earlier about being like reductive or reductionism, the true reductionism is when you categorically ignore and dismiss something. That's the only way you can reduce, in my opinion. Now, if you're wondering, okay, but if you discuss something and it gets more efficient and we ruled out certain things, isn't that reducing too? That's refinement. So yes, it is reducing in size, but you're refining based on the collective information, not reducing and reductively dismissing information because you don't want to hear it or you don't want to even consider it. So refinement is a positive thing oftentimes, like more often than reducing things. So if you choose to ignore something because it's not in your interest, then you are being reductive. It doesn't matter if the thing you're not interested in is something you don't care about, or like it's redundant, or it's saying the same thing. You are ignoring information. So it's reductive. You're reducing someone or something or some information to exclude it. That's reducing. Refining is when you take in information, however relevant or redundant it is, and then refining your perspective. And through that exchange, there's a chance of emergence. And that's kind of how I describe chemistry, biology, and physics and whatnot. In fact, it is really interesting to... I wonder, like, if you can ask someone who's a historian, like a scientific historian, not the same as like physics and chemistry, but someone who studies the history or attempts to study the history or the etymology of disciplines, like scholars, to see like you could maybe find an interest in the discipline's emergence. Like, when did physics emerge, or when did certain principles emerge? Because I think that'd be very interesting. I think that's probably something that you would be right down your alley, Procol, because I feel like you give me the impression that lineage is quite something that you might be inferring as well, especially when you look at the like relationship between physics, right? Physics, chemistry, and biology. And also, I'm drawing these arrows intentionally in this direction, or like, for example, Britannia, right? England, and then the UK, for example. Like, there is truly a factual, right, quote unquote, a factual way of looking at emergence, which is the idea that you're thinking, well, there's a small, and then there's a large, and there's a simple and a complex. A first and a later, right? So it would be kind of interesting to hear theorists like a scientific historian or something that has attempted to chronologize, did chemistry come first, or like this bio topic was labeled as a biology and then it became emergent as a chemistry thing, like which order it is. I typically don't think of things as ordered because I wasn't born in order. So like I studied biology. However, whether biology led to physics or led to chemistry, for me, bio came first, right? It's not that it is factually first or factually most important. My perspective is that it's all important. And my life is only limited to the point where I have to draw priorities on how long I spend, commandeering chemistry and physics to study a problem that I'm interested in. And then I hope, which again, if I had to take a gamble, here's a hot take. I no longer work in science, so that might contribute to this. I think all of it is important. But as you can see, my life is not going to get anywhere near this. So we have to prioritize. So I kind of understand when you think about things being reduced, like reductionism, which one's more accurate, which one's more precise, which one is more important, so to speak. Like, is physics more important than biology? Because if we focus all our efforts on physics, then we can explain all of biology and chemistry. Like, those types of perspective, right? My hot take is all of it is important. And whether what comes first or what comes second, all of it will be emergent. And as humans, we are part of a linear chain of time. And we are inserted to what is going to be and what has already been. So constantly thinking about first and last is something that I rarely do. So that's the same as most important and least important. Are things that come before more important than the things that are to be? Or the current present? All of it is important. As humans, we only have limited lifespans, and we want to appreciate as much it is that's germane to our present state, or our near future state, right? And maybe our most recent past. And not so much more. Oh, which, by the way, Prokal, I don't know if you saw... I'll give you... here's an interesting video on... So, John Green... I don't know if you're still here, but John Green, his most recent Vlogbrothers video, he was talking about memory. Like how memory works, like a flashbulb memory specifically. I'm not sure if you're familiar with the phenomenon flashbulb memory, but it is kind of related to this. Oh, you just remember, what is the show you recommended last time that was here? Oh, Eureka? Yeah, Eureka. I'm on season 3 right now. However, I was looking at the I was looking at the reviews, right? So season 3, it kind of like dipped, but it ended on a peak. So apparently season 5 is really good. So I'm really looking forward to it. However, this season, this show did get canceled. However, Sci-Fi gave them one last, they gave them a reprieve to conclude it. So technically it got concluded as, which I am looking forward to. Season 3 is like, it's getting like in the weird territory. But there's a really fun one here. I'll give you a teaser of one of them. A fun one was they replaced, so someone got temporarily fired. The main character temporarily got fired, and he got replaced with an AI robot. It's a pretty good episode, and they were contrasting between human intuition and objective protocol. So the idea of using objective based observational statistics, right? Things that are based on your enhancement of protocols, and then human intuition. So it was kind of like the juxtaposition was your classical thing, and you can use your imagination how that turned out. But it was very clever. Like, it actually demonstrated the, like, one of the little T's that you probably know is they demonstrated that they seeded the idea that this set of protocols can possibly appreciate intuition, right? So it wasn't just black and white where, like, oh no, a robot can't feel and all that stuff. It was talking about the semblance, like there is a potential of creating semblance of connecting the dots. So pretty interesting take on that. Anyways, so John Green, I'll probably link to you a little bit later. I linked to you a Hank Green thing earlier because it was related to our last conversation. Here, the newest one, by coincidence today, was the topic I was going to talk about. So this is related to the topic I was going to talk about. So John Green, it was his turn. He talked about memory. And he talked about it through an anecdote. Anecdote about how he was going to go back and give a speech, you know, like a graduation speech of sorts. Right? What do you call them? Like a spotlight speech or something like that, you know, like graduating class type of deal. And he found out that his graduation speaker, he always thought it was someone, right? And it turned out he thought it was I forgot his name, but he was a Giamatti. And after some internet perusing, and like, I don't want to, like, I'll let him speak for himself. But some people say, wait, Giamatti? Like that Giamatti? Like Paul Giamatti? And this is an older fella. So this, he was like remembered for being like a colonel or having like some sort of position, right? It might have been a football club, but the position. And it turns out that Giamatti that he was talking about that spoke at his graduation was the father of Paul Giamatti. Now, this is not where the point of the story was. It was a tale that he thought was accurate, but after doing some digging, it turned out it wasn't Paul Giamatti. Like, it wasn't Paul Giamatti's father. It was someone named like Vence or something. So his take-home message was the idea that memory is dynamic. It's also tenuous and consolidating. In fact, he echoed this sentiment that sometimes the most scariest things... Oh, sorry, could I repeat the last minute? So John Green, in his little recent thing, he talked about like being nervous about giving a graduation speech, and he reflected on how he thought that there was a Giamatti that spoke at his graduation speech, right? And then through some rigmarole, the public, you know, his audience, became interested, and they found out that the Giamatti he was referring to was the father of none other than Paul Giamatti, you know, the actor that I'm of it's so coincidental. Like, of all the people, Paul Giamatti is one of the one of the people. Anyways, in this anecdote, but then because of that like interaction, he did some digging and turned out his memory of his speaker wasn't even the person. It was someone like Fence or something, or Vance or something. And he tried to do like a little rationale. Maybe it just sounded better how he so the twist was to make a commentary on memory, like human memory. And he introduced the idea, which I am familiar with, the flashbulb. It's a psychological phenomenon, flashbulb memory. And that is the idea that there are things that you know very vividly, like you think is very accurate, but it can also be incredibly inaccurate. So he made a really wonderful comment that I talk about quite a bit, and it's the idea that memory consolidates, it's dynamic, and rarely is it seen more as a record. Is that what flashbulb memory is? I am not a psychologist, so my description of flashbulb memory is highly vivid and detailed and long-lasting memories, and is usually incredibly emotionally charged. So, you know, whenever we think about negative memory, right, they're often emotional and they're often very significant. So are positive memories, right? So are sad, like anything that it deals with this. The thing is, though, you might know the ongoing features. However, they can also be very unreliable. There's a chance that they become the source of unreliable memory. Like, what I mean is, you cannot write based on how vivid, how long-lasting a memory is. Like, it's not correlating to that most of the time on its accuracy. So it was a statement on keeping in mind that human perceive memories. They consolidate and recall memories. They reconstruct. They like the memory that we have is in flux. It's incredibly dynamic. When you go to bed, when you have more memories, they consolidate together. So despite having something so vivid burned into his statement, he found out that his memory was incorrect. Now, he didn't say, oh man, he tried to be hopeful. The idea is that humans it's not to treat memory like a recording device, like the way we remember things and perceive things. One of the boons of our memory is creating emergence. So this is what I mean, and it's connected. Sorry, I like pretty much led you to this moment, but memory is emergent very, very often than not. So oftentimes when people think about the collective wisdom of humans, right? We record things, we write things, we take tools that will capture those moments in their details. However, when we think about our importance, right? The things we know, the things we perceive, the things we do, even memory itself is emergent. When you collectively create more memories and narratives change and narratives get consolidated and refined, and flashbulb memories, the ones that most people refer to because they're the strongest, long-lasting, the feeling of security about our flashbulb memories, they classically also have ways of becoming emergent. And I'm saying emergent because I feel like it sounds more positive. The other word would be to simply say you forget. and consolidate, which is not as great. Like consolidate is like a neutral word and forget is a negative word, right? So whenever we think about our motivations and our thought process and how we develop our skills, I have often treated our memory as emergent. So whenever you're talking about, do I need to relearn something? Well, yes, if you forget it, if you forgot it. And then it's like, well, do I have to practice? Well, yes, because consolidation, refinement, and consolidation. And then how does this relate to everything we've talked about today? A scholar expects to do both of these things. And they expect their memory to be emergent. If you constantly fight yourself, like for me, what John Green was trying to say in the undertones, at least in my opinion, is that you must look at your memory as something to treasure, like to use when it's available. Constantly fearing for forgetfulness, right? Forgetfulness, or constantly trying to treat your memory like a recording device. In my opinion, he didn't say this outright, but that leads to a lifetime of anxiety and like conflicts of interest, misunderstanding of, in my opinion, a truer nature of humanity's memory. Like you perceive your memory. You're not recording things. That's why cameras are awesome. Like recording devices are awesome. Technology is awesome because it's compensating, or not really compensating. It's doing something we as biological, like the way our brain works, right? For example, we are not responsible for doing that. We created tools to be able to do that, right? And it is those tools that aid in our understanding, but our memory should not be treated like that. It's like trying to be something you're not, at least in my opinion. I think he worded it in a more hopeful way and maybe a little bit more ambiguous way. And for myself, I'm trying to sound as positive as possible because I think there are people in life, especially scholars, that may not end up doing this. They like the idea of learning, but they treat their memory like it's permanent. And they don't like the idea of practice. But practice is internal. So if I had a hot take, like maybe a cool saying, John Green is way better at saying like cool things. If I had something, live life by learning. And practice, right? And or live life by learning and enjoy practicing. Because you're gonna be consistently learning. However, practicing is inevitable. You gotta at least enjoy doing the practicing, because your memory is tenuous, right? So knowing that you're never going to permanently learn something, like permanently, is what I'm trying to address here. It's not permanent. That's the part that it was the core of John's anecdote, is that even despite knowing something so well, he was absolutely convinced that vividly, emotionally, even everyone collaborating, he was mistaken. And it led him to the practice of looking at different ways of invoking the memory. And then he made new memories. And then that memory is now different. So because he found out that it wasn't the right speaker, he made a new memory. So that memory now is emergent. And guess what? That story about the Giamatti's father, right? I forgot his first name. We're just gonna call him Jake. It's something like Jake. Jake Giamatti, right? Paul Giamatti's father. will be tied with, I think his name was like Fence or something, like Mark Fence, or we'll just call him Mark Fence. I really did not catch the name. It was mentioned like once or twice. Now these two things are going to be tied together, at least for the time being, temporarily. And this is what makes humans emergent. For better or for worse, we are not recording devices, right? And even despite practicing all your life, still not recording devices. The idea is emergence happen as well when your memories are not collectively the same. Like, think about it this way. If your memory is always the same, can you might argue, well, of course you can. If your memory is always the same, can you form new experiences? I don't know. I'm just curious. So, like, if you remember everything exactly the way it is, like your new memories, for example, when you have new memories, right? And then your new memories interact with your existing memories. If they stayed compartmentalized and always the same, can you form new experiences? I've always wondered that. We can't answer that question because for 99.9% of humans, it's not true. Now, there is, you notice it's not 100%. There are human beings. There is a human being that had a YouTube channel. I watched like a few of his videos. He has this thing that allows him to like constantly relive or like encode emotional memories. And the way he describes it, it's not because of new memories or like creating new things while he's reliving the old memory. He relives the old memories. So that's kind of an interesting thought. So the way we are now, right? Like how we can experience nostalgia, for example. Is nostalgia because we are recalling the same memory? Or is it because we have new memories that are interacting with our old memories that create the feeling of nostalgia? Right? Because they can be compartmentalized. If you try to compartmentalize them, it's like, oh, that's interesting. But that nostalgia comes from being away from the thing. It comes from comparing it with what you have now. So your memories are interacting with each other. Like a robot, for example. If a robot has 2 units of memory and they're kept separate, do you think they can experience nostalgia? I wondered this quite a lot. Like, this might be one of the things that make a human a human. The idea that when you have a new unit of memory, they interact with each other. They're not seen as separate things. So whenever you're trying to record something, right, record in your head. When you're recording new things, can you keep them separated over time? For me, no. It's never separated. Like literally, I would spend hours telling people, how do I remember this? Right? Someone asked me like, how do you remember these vocabulary words? Technically, you could remember them as a separate unit. Like you can try to separate them. Like you just remember smirking as smirking, right? It's always as smirking. It's like, no, that's not how memory works. In my opinion, the way you remember things, or at least the way I remember things, is by association. So when I get this new word, it is related to its context. And some of these contexts have existing memories. In fact, the more existing memories you have when you're learning something, the more likely you will remember. The important parts, aka the flashbulb stuff. It's not really the flashbulb stuff, it's flashbulb-like. So the things that encode better are the ones that you have a memory interacting with another memory. So your existing memory is stronger when it's interacting with something that it already exists. So oftentimes when you're learning a language, now we're going to bring it back to language learning, because we got to bring it back to language learning. When you learn a language, some people would argue, yeah, just forget you know English and just pretend you only know Japanese. Okay, I mean, that's certainly one way to go about learning it. I don't learn that way. My memories are most vivid when I imbue as much of my old existing memory with my existing new memory that I'm trying to create. And then I treat my new and old memory as emergent memory. And to me, that represents something. Obviously neurobiology can change all of this and whatnot. That I don't think I'm going to live long enough where the brain is going to be redefined, like a paradigm shift that completely uproots this like theory or narrative that I'm presenting. But the way I'm treating it is how I think neurons work. So the idea is that you form neuronal networks, and when you create a new memory, you are consolidating two sets of memories together. You can try very, very hard to keep them separate. And if you try to keep them separate, you have to double your actions. So, yes, there are people who would do that for the rest of their lives even. They can probably do that. So when they speak Japanese, they can barely translate into English. Sure, maybe. I don't know. Like, they would never think of two different languages when they speak one. That is interesting. I don't know what that's like, because I don't think that way, at least in my opinion. Your memories are always interacting with each other. So to try to think of your memory as, for example, a hard drive, right? A hard drive, that's where emergence kicks you in the face, because the human brain is emergent from the hard drive analogy, or the other way around. A hard drive is dealing with the original storage of it, but it doesn't deal with how human memory is accessed. and encode it. It's closer to a massive Chinese whisper game than it is. Yes, exactly. A massive Chinese whisper game. I love the massive Chinese whisper game. Like the idea, like what the TikTok, even the TikTok trend, like in language learning, there's they play the Chinese whisper game where they have different languages. So like people who speak different languages, but they don't they all speak English, but they all have different languages. Like their principal, like their mother tongue is different. And then they do the whisper game and it's wild. It's absolutely wild. Like, you know what? If we wanted to think about a hard drive, the human brain is a hard drive that has like a 90% corrupt rate. I'm just kidding. Or like it always have with like it corrupts very easily. Right? Every new write, every new rewrite, and it's a single read. It's a serial series encoding. Basically, like when you have to recall something, you rewrite over the partition and adding, like, rewrite the partition, and it has a high corrupt rate. In fact, it's simply just rewriting it. So when you recall a memory, right? Like when you recall this memory, when you read this, it's going to create a memory, or it's going to pull a memory, right? Hopefully, like the act of doing something. And then when you encode something new, this memory becomes attached to this memory. So that whatever that position is, it's going to be modified. Biologically speaking, you're like, at least that's my rudimentary way of talking about neurons. It engages the actual neuronal network that is required. And then when you associate something with it, then something else has modified it on top. So now it's both. That is the new memory that you have. Your old memory, the memory that you think is like segregated away from this new instance, that doesn't persist anymore. Like it's both. So that's what I mean by memory is consistently emergent. You cannot, in my opinion, I think it is a lot healthier. Not that I'm saying that it's true, because I don't actually know it's true because of neurobiology and the lack of scientific evidence and all that stuff. My thought is when human behavior is in line, it's incredibly difficult to know if are you consistently creating new memories, or are you using old ones and then those old ones stay static, right? Like that's how people imagine it, where like you store something in A, and then when you think of A, you're actually creating a B and storing it separately, right? And then adding the new information. So this is A plus B. And then there's still an A somewhere. Like it's still A only somewhere. My thought is it's probably A is now B with A plus B together. You're modifying your memories. Your memory is consistently modifying. And to me, this is an elegant way to explain nostalgia. Just think about it for a moment. Nostalgia, like why, if you hated something, right? If you hated something the first time, and then somehow later down the road you look back, and now it gives fondness. Technically, if this unit was separated, it was just completely separated, you would still specifically just feel the hatred. Like if this unit was like untouched or somehow unmodified, you would be able to elicit it, like relive it, right? But typically you don't. Not usually. Sometimes you hate it more. Sometimes it's not a big deal, right? Sometimes it's completely different. So, to me, even nostalgia is a consequence of knowing that when you recall a memory, you're making a new one. So, when you engage, this is where when I hear people say, life sucks, it's not like the good old days, right? And oftentimes my first thought is like, okay, well, it kind of sucks that your life is like, you don't perceive your life as being better or worse, or it's being worse than before. And whenever people say, well, it's not like I remembered, right? Not like I remembered. And oftentimes my first thought is, it's never going to be like you remembered. In order to feel this way, you have to have the interaction of what you remembered with what's currently happening. So every time you recall a memory, you're literally evoking it again, the current state of the memory. So like, when you think about something again, you're evoking it again. As in, like, you literally have to remember it again. So that's going to interact with everything that you're currently doing. So when it comes to like behavioral psychology, this is where it gets really interesting. If you think about something in a different condition, under a different condition, somehow this creates an adaptive response, right? So here's a good example. You play video games while learning physics, right? And say the physics is about memory A. But back in the day when you were in school and you had memory A and it sucked. It absolutely sucked. The only thing you remember is it sucked. Now when you play video games and learn that same principle, somehow it doesn't suck. Right? But it's still the same physics thing, right? Like if they presented it exactly the same, but somehow you were doing something else in the process, it sucked less. So you could argue, oh, well, that's a modification of that physics thing. But do we actually remember how much it sucks? Well, you could say, oh yeah, it did suck before, huh? Right? Like, oh, this sucked, but now it doesn't suck. And then it's gonna cease to suck. Or suck less. And sometimes people might even forget why it sucked in the first place. That's the funny thing. Like, oh, something good and your flashbulb memory is even more powerful. So then you're like, wait, why did it suck in the first place? This isn't so bad. You've heard, you probably said this. I've said this. Like the idea is like, man, I don't even remember why I hate this. But you are more likely to forget something if it is integrated into something else. At least in my opinion. So like if a sucky moment is then linked with a successful moment, oftentimes the thing that takes most priority ends up displacing the thing that isn't. And what do we call that, in my opinion? We call that things like overcoming grief. Right? overcoming adversity. Possibly even coping, honestly. That's kind of what I mean. Like there are so many things that kind of alludes to the idea that memory is plastic, right? Or what is that? That's not the plastic, not in, oh, I'm sorry. I'm using like it, I'm misleading. Like plastic, not like sorry, I meant like plasticity. there's plasticity in, like, there's malleability, and it's like it can change. Like memories, it's a dynamic process, not a static one. I don't know if this is gonna like make people upset, like, oh, but what if I want to remember something? Like, you will. It just doesn't stay the same. Yeah, memory is plastic. Like, if you think about it, Pro Call, when I said memory is plastic, someone's like, wait a minute, but plastic never changes. You know, like, if they think about like polyethylene glycol, right? Like, wait a minute, plastic is just like, and I realized, oh, I'm using the science term plasticity, where it's like your brain has plasticity. Anyways, I personally, that's what I think. So I live life like that. Some other person could like come up and try to argue with me, and I'll try to integrate their ideas in order to create new emergent ideas about, you know, the brain. Like, if new information comes out, we'll revisit this. Personally, I study, learn, talk to people, get to know people, form relationships. I talk to people like this. I do not talk to people like it's static. So like Pro Call, when you mention, like, we keep revisiting, like you said, like, oh, it's kind of like our favorite conversation about biochemistry, biology, and physics, right? This natural inclination, I don't know if you already done this naturally before you met me or not, but I talk like this to other people. And through my experience, 9 out of 10 times, the people who know me form far more frequent memories and consistently have a more like long-lasting impression than treating memory as static, like events as static. Like, there's no reason to repeat a discussion. There's no reason to rewatch something after a period of time together. There's no merit to anniversaries. There's no merit to celebrating the routine of doing something 100 times with the person you like. Like, all of these things, those are the things that go away when you meet someone who believes that memory is static. Like, there's no merit or a value in revisiting things or consolidating things or looking for new emergent ways of looking at things. Like, you could go back to your high school, I don't know, essay, and when you're reading it now, it is going to evoke so many different things if you so choose. I think most people try to convince themselves that there is nothing interesting ever to be had when you're thinking back to something, or literally walking back through the steps. Even watching your own recording, like you record something and you watch it back, there's no merit to that because you believe that memory is static. Like, if you've already done it, there's no reason to ever do it again. That's not how humans work, at least in my opinion. Your memories does not work like that. Sure, the camera might work like that, you know, right? Like, the video game might work like that. You do not work like that. So the reason why I want to emphasize this is those who feel like they're stuck in place, like they can never find interest unless it's something new or something that they can comprehend without adjusting anything that they believe. I don't live in that world. That is like talking to someone who says, I've always believed this and you can never change my mind. Or you can, and what I mean when they think about, they're talking about changing their mind, they mean like discarding their existing memory in order to embrace a new memory. I'm like, it can be both. It can be all of the above. When two people share ideas, they create new memories. Whether or not the two people recall an old memory. Like when two people recall an old memory and they share it together, those two memories become associated together for those two people. That's what creates shared experiences. That's the closest thing to empathy we have. So yes, there is a point to watching a movie again, even if you've seen it already, with another person. Let alone watching it again like 2 years down the line, because your brain, in a way, can seem as a negative can also mean that you can relive something. Like, think about that. Think about how crazy that is. Nostalgia is the act of reliving something. So if you are someone who believes your memory is static and it's like stored forever and it just recedes over time, that's how you explain why your memories keep changing, or like your memories, you're just forgetting. That's all you're doing. You're forgetting things, right? Then that sucks for nostalgia too. Because if you remember everything that you are experienced, nostalgia is not that great, honestly. Like, it's just like, oh, well, I've already done this. It's like, it's boring. But no, you don't experience, like, you're just recalling what it's doing. Like, you can't. That's what makes nostalgia possible, in my opinion. Like, it's one of my topics that I want to talk about when treating nostalgia, because right now online, here's one big, I won't go into this too much, maybe a little later down the road. Nostalgia chasing is a very common thing now that everything's recorded. You know, the internet now has a new medium. Now, internet medium oftentimes deal with boredom. And boredom deals with seeing the same thing again. Like the same exact thing. So now there's a tendency to do slop or iteration in order to try to compensate for the same nostalgia. And this had started occurring for the last like 2 or 3 years. And consistently, in my opinion, this failed to address boredom. In fact, nostalgia tends to happen with the original thing. So now you might be arguing, okay, well then doesn't that just explain that our memory is the same? It's like, well, if it's the same, it would end up being boring. Like, no anticipation, no nothing. It would just be like you wouldn't even need it. You wouldn't even need to recall it. Like, what I mean is you don't need to relive it. You don't need nostalgia to relive something if you remember it. So to me, one of the functions of nostalgia is that your memory is no longer there. It is transformed. It can be transformed. It can be groomed. It can, it can mature. There's so many things. So nostalgia is the act of reliving something that you no longer recall in its entirety. Because if you did, there's no need to experience it again. You can simply recall it. And yes, I do understand that some people have nostalgia just by thinking about the moment. Like you're like just if you sit here and you're like, oh, I feel nostalgia by thinking through the moments, right? The thing is, what's eliciting that emotion is like you're literally doing it again. Like you're evoking the memory, right? Like there's a biological consequence of evoking those same neural networks, those things that are attached to it. You're not a computer that has your emotions and all your other stuff separated from like some unit of storage device. So this is it's not very elegant because I need to work out the connection. The idea is there are people who the way they view nostalgia and memory and whatnot, they are often in a cycle of trying to they have depressive associations with how memory works, right? Like, oh, wow, this is not as good as I remembered it was, or wow, this is so much better than it was. Those things don't happen when you can't appreciate that memories are not static. So for example, when someone hates something, right? When someone hates something, it can never be any different. As in, you hate a movie, you're never going to watch it again because you know for absolute certainty it's always going to be the same. And because of the internet, then in the future, any future movie that resembles the movie that you hated will also convince yourself to guarantee that you'll hate that movie. Because if you know what's in that movie, it's always going to be the same as the movie that is similar to it. That also works the other way. If you like a movie, your anticipation is that it's always going to be a likable movie that is related to that movie in the past. Those interactions are going to create new memories. And living a life thinking that your behavior is always going to be dependent on your actual memory is kind of a tough life, in my opinion. It can lead to the idea like, oh, I'm surprised how much I hated this movie, even though I clearly remember I absolutely love this type of movie. Or, man, why is it so boring now? And I just don't like these games anymore, despite knowing and remembering that I used to love these games. Or, why does this playground seem so much smaller than I remember it? You know, that type of thing. Also, you have to go now, but there's been very interesting topics of conversation. Obviously, I'll keep listening to you, but no worries, no worries. Thanks, Prokov, for stopping by. It's always been a pleasure to brainstorm and theorize about things. We're literally like, you know, the idea is when you show up, we're doing the thing. I'm literally trying to do the thing that I'm talking about that I believe in. When we keep on talking and we iterate and refine our memories, it becomes very salient, strong, and transformative, right? Or in other words, emergent. So that's why I speak the way I do and why I link and circle around topics as consistently as I can, because I don't take my memory for granted, or I personally do not believe human memory is treasured in the way other people believe. Like you and I, or at least I don't think I have an eidetic memory. I'm not gonna try to gaslight other people believing, so I try to explain the way I talk. It's always worth the good old discussion. All right, let's finish this. Let's see if I even recall this stuff.
彼女はニヤニヤしています。
Nya nya. And the only reason I know nya nya is because I thought of nyanyan. Nyanyan, the comment I made earlier about nyanyan. All right. What do we got this? 降り出す。
雨が降り出す。
降り出す。
あなたの名前は何だっけ？
なんだっけ? Interesting. 旅行会社ね。会社. Yeah, I told myself, I even told myself that I needed to remember the 連絡。
兄は旅行会社に勤めています。
会社。And, study, we combine fee with the act of studying. So, 授業料。
授業料を下げてあげました。
And this one was new. It took fertility plus use, the other use. So, heck, une? Oh no. And then Zukai. Zukai. But I lost the read on the new character. Muda Zukai.
水の無駄遣いをしないでね。
Right, the fat horse. Yes. Alright, that was a good place. Good place to have a nice, decent little rant. Okay, folks, that's a wrap for Bunpro today. If you're gonna watch this later, arigatou gozaimasu. As always, feel free to follow along, pick up Bunpro for yourself, give it a go. You're always welcome to come on by, chat, discuss, share our thoughts, feelings, what have you. Construct new memories, right? Construct new memories, refine old, integrate the old with the new. Always a good time. Until next time, 皆さんまたね。見てくれてありがとう. Thanks for watching. I'll see you guys next time. I'm gonna get up and walk around, stretch, and I'll be back for Hanza Hero. Thank you.